You know, it's pretty wild when you stop and think about it. Your car has senses, not just in a metaphorical way. I mean, a whole suite of electronic eyes and ears all working together, building this incredible picture of the world around it. Today, we're going to get into the amazing nervous system of the modern car. So, how does your car actually see a pedestrian or a stop sign or that car creeping up in your blind spot? And here's the real kicker. As we all start shifting from gas to electric, how is that fundamental change completely rewiring a car's senses? Okay, let's get into it. All right, here's our game plan for this explainer. First, we'll cover the basics of a car's senses. Then, we'll break down the core sensors that make it all happen. We're going to look at the magic of how they'd all work together, how the big EV shift is changing everything, and finally, what the road ahead looks like for this incredible tech. To kick things off, you really have to appreciate just how insanely complex driving is. It demands constant perception, lightning-fast interpretation, and immediate reaction. And that's exactly where a car's sensory system comes in. It's designed to handle this huge challenge safely. And this quote? This really nails the mindset shift we all need to have. We're way past thinking of cars as just mechanical things. Today's car is, for all intents and purposes, a powerful rolling computer. It's defined more by its silicon and its software than by its engine, and that transformation is at the heart of everything. And the speed is what's truly mind-blowing. To react to someone cutting you off or a person stepping into the road, the car's brain has to take in all that sensory data, process it, and make a potentially life-or-death decision in as little as 10 milliseconds. That is literally faster than you can blink. So, what are these actual eyes and ears that are feeding this super-fast brain? Let's meet the core sensor suite that powers all those modern advanced driver assistance systems. ADAS, the features like automatic emergency braking and lane keeping assist that we're all getting used to. The two big workhorses are cameras and radar. Just think of the camera as the car's eyes, right? It gives you rich visual detail, lets the car read signs and figure out what something is, a cyclist, another car, a traffic cone. Radar, on the other hand, it's kind of like a bat's echolocation. It is fantastic at telling you how fast something is going and how far away it is, and it works great in fog or heavy rain when a camera might be totally useless. And then you have LIDAR. This one is the real game changer. LIDAR basically shoots out laser pulses to build an incredibly detailed and super accurate 3D map of everything around it. That precision is exactly why most experts say it's absolutely essential for true self-driving. We're talking level 3 and beyond, where the car can pretty much handle everything itself. So you can see there are these core trade-offs. The camera is awesome at telling you what something is, but it's terrible in bad weather. Radar is an all-weather champion for speed and distance, but the image it creates is really low res. And LIDAR gives you that stunning accuracy, but man, it's been expensive and can still get tripped up by weather. Here's the key takeaway. No single sensor is perfect. So if no single sensor can do it all, how in the world does a car build a reliable picture of what's going on? Well, that brings us to the magic of sensor fusion. This is where the car's brain takes all those different inputs and combines them. It boils down to a pretty simple but incredibly powerful three-step process. First, the car senses the world with all its tools. Second, a central brain, the ECU, makes it think by piecing all that data together into one solid picture. And finally, the car acts, making a much smarter, much more reliable decision than any one sensor could ever make on its own. And this is why it's so important. The whole goal is safety through redundancy. So if your camera gets blinded by sun glare, the radar can still see the car slowing down ahead. If the radar gets confused by a metal can on the road, the camera can see it's harmless and tell the car not to slam on the brakes. That overlap is what makes the whole system so robust. Okay, now let's plug all of this into one of the biggest changes in the history of cars, the massive shift to electric vehicles. Because this isn't just about swapping out the engine, it is fundamentally changing what a car needs to sense. And it's speeding up the need for an even smarter electronic nervous system. What we're witnessing right now is this great sensor swap. The market for all those old-school engine sensors, things for fuel and exhaust, is going down. Meanwhile, the market for ADAS sensors like LIDAR is just exploding. And the so what here is huge. It's not just about new parts. It means the real value of a car is shifting away from its mechanical power and toward its computational intelligence. I mean, just look at it. The heart of an EV is this massive battery pack. An old engine had its own sensors, sure, but this battery needs a totally different, way more complex suite of sensors. They aren't just watching combustion, they're managing chemistry, they're tracking temperature in hundreds of individual cells, and they're constantly calculating the state of charge to keep you safe and performing well. So, yeah, the whole priority list gets a rewrite. The battery management system, the BMS, becomes the brain of the battery. It's one of the most critical safety parts in the whole car. Tire pressure monitoring suddenly becomes way more important because EVs are so much heavier. And telematics units, the things that handle wireless communication, they become absolutely essential for sending data and getting those game-changing over-the-air software updates that can literally make your car better overnight. So we've seen where we are, but where are we going with all this? Well, the road ahead is packed with both some really exciting opportunities and some pretty significant challenges that still need to be solved. Here are the big 4 hurdles the industry is tackling right now. Cost is still a huge deal, especially for those high-end LIDAR systems. Getting sensors to work perfectly in all weather is still the holy grail. As these cars get more connected, cybersecurity becomes a massive concern. And finally, the sheer amount of data these cars generate, it's just staggering, and it takes immense computer power to process it all. But the future is looking incredibly bright. We're seeing solid-state LIDAR emerge, which is smaller, tougher, and cheaper. AI is being used to make that sensor fusion even smarter, teaching it which sensor to trust in any given situation. We're also going to see vehicle-to-everything communication, or V2X, where cars can talk to traffic lights, to infrastructure, even to a pedestrian's phone. And get this, we're even developing cameras inspired by the amazing efficiency of the human eye. How cool is that? So our journey has taken us from these simple individual sensors to a really complex, fused worldview. The technologies we're seeing now are closing the gap between just reacting to things and something much more profound. Our cars are mastering the art of sensing. So the real question is, how long until they master the art of anticipation?